Stars are whispering tales of old, planets spinning, stories bold. Life is dancing through the night, countless worlds in the starlight. Galaxies full of mystery, infinite in their history. Beyond our dreams and our sights, life blooms in the cosmic lights, dancing on the edge of space. Take me away, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Nebulas with colors bright, birth new wonders in the light. Comets trail their sparkling tears, life endures through the years. In the silence of the void, every heartbeat is enjoyed. From the depths and to the heights, life expands through cosmic night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless
Hey, welcome to SkyTour Livestream. It is I, Mark D'Antonio, here with you, along with the ever-present and omniscient Daryl Mason. Hi, Daryl.
I knew you were going to say that.
Oh, that's why you're omniscient. Good call.
Hello, everybody. Hi, I'm good. How are you?
That's great. Hey, so tonight, this is the we're looking here at the Sonoran scope right now, and we're looking at the star Sirius right now. So I just use it as a calibration star tonight. Okay, so that's Sirius, and I am serious. But as far as getting some interesting views of things, the moon is very bright right now. It's a waxing gibbous, so we're gonna actually just see what happens when we go to the Orion Nebula and check that out. So the telescope's on its way there now, and you'll see that our little crosshair here is going to end up going zip over to the nebula, and we'll see the Orion Nebula show up in the screen here, and there it is. All right, now I haven't done critical focus yet, so I will. But there's the size of the nebula in the wide field scope. This is the wide field scope out in the Sonoran Desert, and it's 220 miles from this one. This is the view in our current telescope right now out on the Benson Plateau, and we're looking at the gorgeous moon with this new system. It's really quite nice. Allows us to see some beautiful things. And so tonight we're going to spend some time with the moon in the view. And I'll tell you why, because what we're going to do is see if we can actually catch a satellite passing in front. And you'll notice a satellite when you look at the screen. You'll see like a little dark dot that's moving across the moon. All right. Now, right now, the way the telescope is situated and angled, okay, we're actually, and I'll show you this, we're looking at the moon a little bit differently, okay? So we zoom in here. You'll notice now, if you look at our name here, our letters, okay, this is the field of view that we're looking at the moon, okay? This is Mare Crisium in this side here. And it's a little bit different from what we see here. And that's because the telescope camera is turned in the holder. We're going to be getting a field rotator, which is going to allow us to rotate the moon any which way we want, actually rotate any scene we want. And it's going to necessitate some machining to remove some length to our what's called our back focus. But we're going to do that. And once we get that installed, then we will be in a position to move the view any which way we want and orient it in the same exact way as we see over in this telescope when we actually go to look at the moon in this telescope. And just for our fun, we'll just go do that right now just to show you what we're looking at. Okay, sorry about that screen being a little messed up. That's just a function. Okay, you'll watch the telescope here is now heading over to the moon. So it's going to get very bright here in a minute. So I'm going to have to drop this way down. Okay, and that's what I'm doing now. I'm going to drop this way down. Okay, so there's our moon. This is the size of the moon in this telescope.
We're very close to Mars tonight.
And it is, and that's why I was going to use this telescope too, because I was hoping we'd be able to catch that. Probably not going to be able to frame them both, but because Mars is just out of our view here, you know. But we're good. We're good. All right, so we can do this now.
Say hi to Marianne, Mark.
Hi, Marianne, Mark. Marianne's with us. Hi, Marianne. I also noticed that we have a Connecticut person in the chat. I want to welcome you to our chat. It's so nice to have you with us. And I will, let's see there. Is it Adrian who's here with us? Adrian, I think it was Adrian who's here. I'm trying to find her in the chat now. Well, anyway, I'll catch her on the way down. I want to say hi to Carl Becker, C&D boy. Kurt is with us. There she is, Adrian Tobin. How are you, Adrian? You're in Barkhamsted. Yeah, you know what, Adrian? I live in Terryville, Connecticut, so I'm actually just down the road from you, down Route 8. I would often go to Colebrook Dam it's a dam, guys, that's not too far from here. I can get there in about 20 minutes. And I go to the boat launch ramp, and I set up out there sometimes to look at the sky, because that's the one place in Connecticut where it's actually pretty dark. And Adrian might be in a fairly dark area there. The lights from Winstead might affect her. That's another little town there. But it's so good to have you. Adrian, I don't know, since you're in Connecticut, on March 26th, I'm going to be speaking at Aquila's Nest Vineyard, which is in Newtown. So if you want to attend one of my talks at all, they're opening the vineyard for my talk. So it's going to be a Wednesday night on March 26th at 6:30. And I'm going to do a talk, and I'm bringing a projector and the screens and all that. And then with any luck, we'll be able to go outside and do a sky watch after. which is exactly what I'd like to do. You know, so that would be kind of cool. That's entirely up to you if you wish to go, of course. But it'd be nice if I had some folks that I'm familiar with coming to see it. So in any case, I'm hopeful that we will be able to pull that off. The Skywatch will be a lot of fun. People will enjoy the Skywatch. They enjoy the Skywatches that I do. I'm going to be in Palm Springs at the end of May doing another Skywatch with good friend Ben Hansen. And then I'm going to be doing about 3 lectures out there at a conference, which would be kind of fun. Let me drop this down a little bit. Show you the moon here. Yeah, so this view of the moon, okay, is with we're in a wide-angle telescope. So the wide-angle telescope does not allow us to see the detail that we might otherwise see. Okay, and so when we go to the other telescope in Benson, okay, what?
I see Tycho and
Copernicus.
Clavius.
Yeah.
I don't know about Copernicus.
Yeah, it's right there. That's Copernicus right there. Remember, we're angled over because we're rotated. That's the problem. So let me do this. Let's see if this will. Okay, let's go more to the south. Okay, and now.
In your current view, the small crater at the upper right is Tycho, and the bigger crater to its upper right is Clavius. That's Tycho.
And this is Clavius right here.
That's Tycho.
No, you're not looking at the live screen.
Well, all right, you keep changing.
Yeah.
Yes, that's Clavius right there.
Yeah. So as we zoom in the movie, as Daryl and I both mentioned yesterday, 2001: A Space Odyssey, or day before yesterday, Clavius was where the moon base was, and it was Tycho Magnetic Anomaly 1 here in the crater Tycho, which was the black monolith from the science fiction movie. Really cool stuff.
You could always tell Clavius because it's got like a row of craters across the from the edge to the inside of the crater. You can see 3 of them there. The biggest one's on the about 12 o'clock on Clavius as we're looking at it now. And then there's kind of a curved row of craters.
Yeah, they're right here.
Going across the inside of the crater.
Yeah, large, smaller, smaller still, and smaller still. It's interesting that the curve. I actually have a printout right behind me of Clavius crater. I actually I have access to the lunar data and the digital elevation maps of the entire moon, and so we actually print out on 3D printers here craters, and people can get any crater from us they want. It's pretty cool.
You gave me Tycho crater, didn't you?
I did indeed, if I recall.
I think it's Tycho.
Yeah.
I need to go find it. It's buried here under my desk somewhere.
Yeah, I mean, people love the little craters, and it's really cool because, you know, I'm an astronomer, and that's what I got my degree in, of course, and so I know what the craters are supposed to look like, and it does help that I'm also an artist. If you're also an artist, then it means you have that technical aspect plus the creative aspect to actually make the craters look like they're supposed to. You know, craters aren't just gray. There are subtle shades of lighter and darker grays. There are subtle shades of color too, and for some craters, I actually put in those extra colors because it's only right, because that's what it looks like. And if that's what it looks like, then that's what I do. So that's kind of fun, and so I really enjoy doing that for people. I just did my stream lighting, okay. So that's Clavius. This is beautiful. You can see if we move this over. Here's Tycho crater with its very prominent central peak. right? And this is the ray structure from Tycho. It goes hundreds and hundreds of miles. So when this struck, in all likelihood, because of the way the rays look, this was probably a head-on strike of a meteor that struck the moon. And in contrast, all right, we see craters that don't have rays. Now, Clavius doesn't have rays, yet it's a bigger crater. So what's that all about? It depends on the impact energy, and it depends on the subsequent evolution of the area around here. So, for example, when this struck, you'll notice that it looks like it has a flat bottom in it. Well, it kind of does. It's actually a lava-filled crater. So when Clavius, the Clavius, this outer rim crater was made, this was just a blank central crater filled with lava, because the meteorite punctured the young moon, and it was able to cause lava to well up, overflood the crater. But then these craters struck at some other point in time. Now, they could have all happened around the same time, which would explain why there might be a neat little string. You know, the moon's gravity could have torn apart an incoming meteor and splashed it in several different areas. And we see that a lot on the moon, okay? Or it could have happened at some later time, you know? And I mentioned the other night, I talked about terraced walls in craters. If you look at this crater right here, that's a terraced wall you can see right there. You see how it has these edges to it? That's a terrace, a stepped wall where it starts low, gets higher and higher, and like stair steps as it heads out of the crater. And that is the function of another type of complex crater. Tycho is a complex crater. Clavius is a complex crater, but its central peak may have been there originally, but guess what? The central peak, which could be right tied in with these craters, okay, over time that lava flooded it out, okay? So some of these craters that look like they're just flat bottom simpletons, okay, might actually have at one time been complex craters, but that central peak was lower and lava filled it up, and it's buried forever under the lava from that, okay? And look how far the rays from Tycho go, all the way out here. See that? Okay.
Yep.
And there's Messier. Yeah, Messier right there. Okay. Here's another example. Look at this crater here. All right. Now, these bright spots here, they're just overexposed right now with our camera. If I was to drop the exposure, you'll see that we can get to a point where, you know, we see them as shades of gray, but everything else is drowned out, because those are actually just happen to be catching the sunlight right now on the moon as the sun is rising on the moon to the midday location, which would be full moon for us. That's where the sun will be directly overhead when you're in the middle of the moon from our perspective.
Interestingly, when it's full moon, it's new Earth from the moon's point of view.
That's true. That's right.
The Earth and the moon run opposite phases.
Yeah.
So if you were standing on the moon, looking up at the Earth, and it was full moon, you would see a new Earth.
Yeah.
And right now, since the moon is waxing gibbous, well, Earth would be waning crescent.
That's right. I want to continue saying hi. Catherine Messick, who's with us. Nice to see you. Carl Becker, I think I said hi. Stan from Two Rivers Observatory. Nice to see you. And Sally Forth, I said hi to you, I think. Yeah, hello. And Daisy and Zoe Amethyst, it's so nice to see you. Along with Lane, cousin Lane. Ta-da! She's finally made it here. Well, it's a good night to see because we have this telescope and we have the other one open. That's the wide field scope 200 miles away from this scope that we're also using. We have both of them open tonight. One's in the Sonoran Desert, west of Phoenix by about 75 miles. And this one here is the one down in the Benson area, on the Benson Plateau. We're at about 3,600 feet here. Temperature's actually a little cooler up there. It's not like it's a mountain, but I mean it's a plateau, so it's a gentle rise. You get up to the top and you say, "Gee, it's a little chilly here." I had to wear sweatshirts the whole time I was there. During the day it was 80, and then as the dusk approached, the temperature rapidly dropped, which is good. You know, we don't mind that. All right, let's see now. I'm going to zoom in a little bit, and I'm going to try to just do a little bit of a focus. You'll see how the air is turbulent right now, so the seeing isn't that good right now. Of course, it's right after sunset. The sky has clouds around in Benson right now, and we just have to deal with that right now. I want to say hi to Stuffy, who's joining us. I want to say hi to SkyTour Live Fan, and also say thank you so much for the donation, SkyTour Live Fan. So nice of you to do it. Dean Bostador is with us. Good to see you. And Keith Evans, hey, how are you, man? Glad to see you. And let's see, Liminal is with us. How are you doing, Liminal? The smallest image this telescope can resolve. Well, it'd have to do with the lunar features, I would say. And as such, I haven't actually done a test. Technically, it has a few arc-second resolution, but I don't know exactly how to measure that on a night like this, where you can see that we're getting some strange activity going on here. I'm gonna see if I can add a little sharper focus here. That went the wrong way. I'm gonna go the other way. I focus manually on the moon. Let's go back one more just to see if that does it. Oh, that might be close. Okay, so
you've got some rather poor seeing going on.
yeah, that's what I mentioned earlier. Yeah, we can try to stack it to see what it does. Okay, and we can just pause that stack. So that you see now, you can see a little more detail in the center of Tycho there. Tycho has these little terraced walls as well. And we'll save it both as a ping and a 16-bit TIFF. So you can download these, of course, from the Moon directory, which is right up there. All right. Very nice, very nice. And then we'll come back to the live view. And again, the reason we have poor seeing is because we have clouds making their way through Benson. If you go to windy.com and you look at the Benson region, you'll actually see that. You know. Hello there, Stephen Smet. That's Mr. Django. C&D Boy, Tim F. Good to see you. Yeah. Yeah, Liminal says, is it correctly? Yes, the peak in Tycho is 9 miles in diameter.
I don't see a folder for tonight yet at the server.
I'm saving them to, let's maybe find out where they're going. I am making a moon folder, so there's got to be a moon folder that's going to show up soon. I've been saving them for a little bit of time now.
Closest I see in the folders is 2 days ago.
Okay, do a refresh. You might have to do a refresh.
Not yet.
Okay, well, it'll be there. Yeah, look at that. That's really pretty. Let's do a snapshot. Alright, so capture 2020 moon. Yeah, it's taking the pictures, putting them in the moon folder with the time. So it's probably just taking time to go. I think OneDrive is running. Let me make sure. Running. All right. Oh wait, it says it's not. Look at that. gotta sign in. I wonder if I already signed in, so I should be okay. Yes, it's me. What's the sign in here? Well, I'll go figure that out. I guess I for some reason had to sign in. That's okay. SkyTour Life Fan says when the moon is full, it looks like daytime. You'll also notice something else about the night sky around the moon. You'll notice that the night sky around the moon at that point, when it's full, looks blue. And that's because the air molecules are doing the same thing that they do with the sun, because this is reflected sunlight it's seeing. They scatter the blue light from the sunlight, whether it's reflected or not. And so when it's direct sunlight, it scatters it, you get a very bright blue. When it's reflected sunlight, you get a rather dimmer blue, but you still see a blue. And many of our images, when the moon gets more full, are kind of skewed toward the blue a little bit, because we're also photographing through a quote-unquote blue sky. Hello, Tiffany Echo. How are you? Tiffany, are you and Mike going to be at Contact? I think I asked you this. I need to know the answer. All right, and let's see here. All right. Excellent. I'm glad you will be there. Daryl doesn't do Facebook. I know. Can you believe it? Okay. Let me do this. Figure this out.
I am a Luddite. Sorry. I still have a landline.
Wow, I haven't had a landline for years.
I don't even own a cell phone. I hate those things.
Okay. Okay, I wonder what. Oh, okay. All right, let me come back to this. Let's try this now. Make sure I did that right. Okay. That's not incorrect. I just did it. I might have misspelled it. Okay. All right, let's do it again. That's wrong. That's going to be the other one. All right, it's going to be this one. Yeah, okay. So it is. All right. There we go. And now it's looking for changes, and it's going to take care of bringing that drive up there. That directory, I mean. All right, let's add a little more.
There it is.
Excellent. Let's add a little bit more. Thank you, Daryl. A little bit more exposure here, just a bit. All right. Clavius crater. This is looking beautiful. Let's see if we can stack Clavius right now. There we go. We can work on that, make it look better. Very nice. And I think that's Evan who has a question for you. He's asking about geodes.
Yes, I see that. Uh, no geodes. I've done a little prospecting in the past. Did a little gold panning. I know of some places you can go here in Colorado where you can collect various minerals or gems or semi-precious stones. Uh, there's a place up west of Colorado Springs called Divide, Colorado, and Florissant. There's, I think it's Amazonite is up there. And if you go over to the Sawatch Range, which is the central spine of the Colorado Rockies, what is it? Mount Antero, I think, south of Mount Princeton, in the Collegiates Range. They have garnets on it and some other semi-precious stones. People do a lot of searching for various crystalline elements up there. Garnets and I forget what the other one is. It's a blue stone, amethyst.
And that's a purple crystal.
When I worked in the mine, we saw all sorts of stuff up there. Amethyst and fluorite and tons of fool's gold, iron pyrite, and the actual miners up there used to high-grade, high-quality mineral samples out of the mine all the time, and they'd sell them to the rock shops in the area. I've heard of pyrite crystals the size of lunchboxes up there.
Wow.
Yeah, there was other stuff. There's gold, of course, which is a longer story, and famous gold mining area is just on the other side of the hill from the mine I worked in, and a beautiful red crystal called rhodochrosite, which a guy I used to carpool with had found one that was worth $1,000, I think he said. That was a long time ago.
Wow.
Just as a sample.
I got a selenite wand. I got selenite, and that's really cool because it likes to diffract light, so it'll diffuse light very nicely too. So I made a base for it with a light underneath and just set it on top, and it end lights it, and it looks like a beautiful, gorgeous rock, mineral, actually, crystal. Hey, Goblin. Hey, Dean. Thank you so much.
Thank you, Dean.
Oh man, that's fantastic. Thank you so much, Dean.
So is this Copernicus now?
Yeah. On the other screen, I have the other one up right now. But yes, over here, this is Copernicus in the Benson scope right now. I can increase the exposure a little bit.
Copernicus, to me, you can see it more so when it's closer to full on the moon. Always looks different than other craters to me. It looks like a big mud splat.
It does, yeah.
Like you dropped a rock into a mud puddle or something.
Yeah.
You can kind of see some of that terrain around the sides of it over up at about 1 o'clock and over at about 9 o'clock.
Yeah, I got it all around.
It doesn't look. The terrain just looks different to me.
Yeah, the what was it? Apollo 14 was over here somewhere. They landed. The purpose of the landing there was to land in some of the outflow rays from Copernicus, so they could sample material that may have come from deeper in the moon, and to see what was underneath. And that was right about there. I think that was at Apollo 14. Was that Snoopy? The lens was called Snoopy.
Don't recall.
Yeah, I don't either. I can't remember. Yeah, so this is good. That's neat. I know, Marianne. Isn't Dean great for doing this? Such a nice thing of Dean to do. Thank you, Dean, again. Yeah, and then let's go down here for a minute because I want to show you Plato. Plato's a very interesting crater, okay? It's right there, the dark one, okay? Because again, it looks like it's a flat bottom crater, but it's not, okay? Plato is so large that its bottom actually curves over the long distance, okay? So it's a section of the sphere through the moon, okay? But just below the surface. And when people say that the craters are all the same depth, well, they look at this, they say, well, this and this are the same depth, and this looks like it is, and this looks like it is, and that looks like it is. It's not. Okay? Using the Lunar Reconnaissance Orbiter Quick Map, the LRO Quick Map, I teach people how to use their special tools to examine the moon. And the bottoms of all these craters are at different depths. And you can draw a line with the quick map. You can draw a line, like say from here all the way through here and stop here, and you get a profile. And you can see what the bottom looks like. Sometimes the bottom slopes up, sometimes it slopes down, sometimes it's a well, sometimes it has a central peak, and it's just very, very different every single time. So I think that's pretty cool, you know.
If you look at, there's sort of a straight line feature to the upper left of Plato.
You mean here?
Yes,
Yeah.
I believe that is the Alpine Valley.
Oh, yes, you might be right. That's right. Okay, and this is Piton, right? And what was it? What was this? Is this Mons Pico or something? Well, I can't remember. There's so much stuff.
Yeah, I know what you're getting at. I can't keep it all straight.
Yeah,
I have a few of my favorites memorized, but I can't keep them all straight.
Yeah.
Thank you, Dean. That brings it up.
Yeah.
Um,
We're stacking it right now. So it's stacking all the best images. So that's good. Okay. And I saved it too, so we're good. Yep. Okay. And we had another question from Sky to Life fan. That leads me to wonder, the moon was made out of debris of the old Earth after what a planet, the collision hypothesis, yeah. Could the moon have massive pockets of crystals the size of towns? Well, okay, here's the thing. It might have lots of volcanic glass, but crystals generally require water to form. And so I wouldn't expect that we'd see crystals by the type you're probably thinking of. Not like selenite or things like that, or the giant crystals in the cave found in Mexico, right? Things like that. I think we got some clouds going on right here, because it's definitely looking hazier there. So crystals like quartz crystals, you're not going to find those on the moon, because again, quartz crystals are formed in the presence of water. And although the moon was probably formed with a lot of water because of the collision with the Earth, there was probably water from volcanology that was going on there. But probably that was gassed out basically over a couple of billion years, a billion or so years. And so after the bombardment era, the moon didn't have water to make crystals. Now, that said, there's tons of water still on the moon. And that's because it's actually locked up in dark craters as water ice. And again, the moon has plenty of water. It's just not water that's flowing so that it can create a crystal vein of some kind. All right. So in the lunar regolith, the lunar soils, remember the L-Cross mission, they dropped a spent stage into Cabeus crater on the South Pole, which is all the way at the other end here. We can't really see Cabeus from here right now. Cabeus has a dark area, its recess inside the bottom of the crater, never sees the sunlight, ever. It's always in the dark. So Cabeus became a site where they went and said, hey, in the dark, these craters, there's probably water. And the L-Cross collision showed water in the bottom of Cabeus crater. That was great. But then they discovered something else, and that was that the lunar regolith, in other words, the soil is the regolith, the soil on the moon has water locked up in it in various amounts, depending on where you are. So whereas we thought, hey, we might have to move to the south pole of the moon in order to acquire and create a colony of some kind, or a moon base, well, if we had to do that, well, then we're stuck up here in the south where the sun very rarely gets into the deep recesses, and that would make things like getting energy a whole lot harder. We wouldn't be able to get energy very well in these dark recesses, so solar panels, things like that, would not be a way to get the energy up here at these areas on the moon that are like that. So what this means to us is that we would probably end up having to use like a nuclear reactor of some kind to generate power for us up here on the south pole of the moon, because of that problem. But as it turns out, over here in the regolith, in this region, over here, and in some of these other areas of these craters, areas far out into the Maria, which are out here and down, or even into the center of Clavius crater itself, we find that the lunar soil actually has a high enough concentration of water that we could farm the water if we needed to. So we're no longer constrained to put a base on the moon at the South Pole, or the North Pole for that matter, of the moon. We actually can do it in many places on the moon and use, as we talked about the other night with Daryl, we mentioned this, we can actually have a lava tube colony, a lava tube thing down there. That'd be pretty good. And Nerd Farm says, yeah, there's an autofocus method, but right now, with the seeing as bad as it is, it doesn't really help. So we are actually, if you notice the undulations here from the cells in the atmosphere, okay, these problems are going to be there, and so we can't really focus any better than that right now. We'd be chasing it, in other words. But I'm going to be doing a lot more and see if we can do that. Yeah, we still need a few other items for the Benson Observatory. Like if I go like this, I'm going to take it out of focus a little bit. Okay. See, that's definitely out of focus. So I come back. All right. And it comes more into focus. And I can chase it a little bit and see if we can get a little bit more out of it. That's slightly better. And it's hard to tell the difference when you get down into these smaller amounts.
I have a question.
Sure.
I'm going to play devil's advocate here. Do we have the right to exploit the water on the moon
as
a resource?
Yeah, there's no reason why we don't, because the moon is like the Wild West was, right? There's nobody that has any claim to it, just like nobody has any claim to Antarctica. You know, we have an agreement that Antarctica is going to always be a wild land, and it's going to be used for scientific research, and that's it. So the moon will probably be similar. So when
But we don't allow mining on Antarctica though.
no, but mining on the moon would benefit the entire planet. You know, mining in Antarctica might benefit one nation. So, but mining on the moon can benefit the entire planet, and as such, I'm pretty sure that the agreements will be made such that mining on the moon can only be done as long as it benefits all of us and not just one company. Now, the government might give incentives to mining on the moon, to miners that want to go mine lunar stuff, but most likely it's going to be automated. I've seen a number of things, a number of proposals that I've read to talk about how they would do mining. And you might have heard the concept of what's called a mass driver. Now, a mass driver, imagine a long track, like a roller coaster track. And instead of little cars that are held onto the tracks, imagine that you have little rocket units, okay? And what will happen is this rocket unit is, say, in one of these craters, okay? And when you leave the moon, you've got to leave with enough speed to be able to break the lunar gravity and get into a coast or a powered transition to Earth. Yeah, translunar insertion is something that would have to happen. Trans-Earth insertion on the way out. So to do that, you need to accelerate a payload extremely fast. And what they might do is make an automated track that's miles long on the moon. And it has a slope such that when the payload leaves that slope, it's moving fast enough that it can actually escape the lunar gravity and start the long journey back to Earth, where it orbits the moon once and then is whipped out of the lunar gravity well and into the Earth gravity well. Now, I'm sure it's been calculated many times before, and maybe there'll be a little power assist on each little transfer rocket. But the idea is that once they got to Earth, well, if these payloads hit the atmosphere, they would just burn up like meteors and they'd be useless. So what we'd have to do is figure out a way to capture them, and there are ideas on the docket to actually capture in orbit these particular payload bundles coming from the moon with titanium oxide in them and things like that, and helium-3 and stuff. And so I think that the mining process on the moon could certainly be automated. Now, to capture the helium-3 is actually quite simple, because, as Daryl pointed out the other night, and as we're pointing out, there's several processes which generate helium-3 in the lunar soil, but one of them is the solar wind. The solar wind deposits helium-3, which is an isotope of helium, into the lunar soil. Now, the moon's gravity isn't strong enough to hold helium down. Helium could just drift away. However, because of the way the solar wind is working, it's the solar wind embeds it into the soil, and so it's held in there by these many particles of soil around these atoms. Okay, so it's embedded. So it's in the top layers of the lunar surface, so in the dust. So if you have a collector, right, on the moon, like a vacuum system, you can actually theoretically sort the helium-3 atoms, okay, from the regolith soil that you don't want, and send back just the helium-3. And you could stick that in a payload, powered or otherwise, and send it down a track on the moon. What would you use to send it down a track? Well, we could envision a rocket-powered rocket sled, of course, but it could be a magnetic mass driver, which would actually have these successive rings that would actually have magnetic tugging going on the payload, and pull it along faster, 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 and faster until it actually reaches, the escape velocity. Another one is the one that is being developed here on Earth. You've seen this big circular, effectively slingshot that spins a payload around and shoots it up into the air. And the idea is that you could shoot something off the moon using a technology like that, which is part of why this thing was developed here on Earth. And it would shoot off the moon with a high enough velocity so that just a small amount of fuel would be required to push it further off into space and head it toward the Earth. And that could actually be a very, very interesting process. That's the use I see for that. And because it could take inanimate things, that aren't people and send them back to the Earth, using that process. I think you know what I'm talking about right there, all that large circular slingshot thing.
Yes.
Yeah.
I think that's kind of silly, but
well, it's not silly if you want to propel a payload off the moon. That's the better use for it.
read the Robert Heinlein book, The Moon is a Harsh Mistress. He was writing about mass drivers 60 years ago, or whenever the book was written. It's a fun book. It's about when lunar colonies revolt from planet Earth government, and they bombard Earth with slugs of minerals with their mass driver, which is what they had been shipping stuff to Earth in. And Cheyenne Mountain here in Colorado Springs, which is where NORAD is or was, they managed to remove Cheyenne Mountain from the face of the Earth. They dropped so much material on it. The impact is comparable to a nuclear explosion, but without the radioactivity. Fun book. I'm having to reset something here.
Okay.
Find Rupes Recta.
That's where I'm going. I saw it earlier, but then we had some clouds come through, and it looked like it was not very helpful. Isn't it down here?
It is north. You might say northwest of Tycho.
Rupes Recta?
Yes, it is.
Well, I'm at the opposite end of the moon.
It is supposedly visible tonight.
It is. I saw it earlier.
I was.
Wait a minute.
I think you need to find Tycho first. It's going to be very close to the Terminator.
It was actually not that far. It was. I don't remember. But Tycho, let's see. Tycho's up here.
Yes, and what you need to do is go to the lower left of Tycho, almost straight down.
Well, like here?
AstroNet view. AstroNet, well, yeah. I'll know it when I see it.
Okay, let me.
I think you may be too close to the Terminator.
No, I saw it earlier. I saw it earlier tonight. It stood out like it was beautiful. It stood right out. I will find it. I will find it. Okay, let's see here.
Go a little farther.
Down here?
Yes.
Alright, let's try that. See, there's Copernicus now.
Okay, that's too far then.
Yeah, it's not near Copernicus. I didn't think it was near Tycho. I thought it was...
Well, it's not that near Tycho. If you could see the moon in a conventional view, where it's not turned the wrong way with your camera orientation. It is above and a little bit to the left of Tycho. That is, it'd be like northwest of Tycho in a
Okay.
conventional view.
Which I'm showing them now. Oh, no, I'm not. No, I am. All right, well, Tycho is right here. So you're saying it's going to be up here. I know you can't see it right now, but it's probably
Yep.
up here.
That's not Tycho.
You gotta wait for it to catch up. You're looking at the YouTube thing now because you can't see the screen.
No, I'm looking at the
This is Tycho.
Skype screen.
I know. I have the other observatory up right now showing them Tycho. And you can't see what I'm doing, so that's why I'm saying.
All right, I see it now.
Yeah, so there's Tycho.
All right,
So
that's
you're saying-
conventional view.
And you're saying it's up in this sea here.
It is northwest of
It
Tycho,
might be right there.
right about there.
Yeah, let me go down here and let me... Alright, so...
I think it's too close to the Terminator to see it clearly.
No, I saw it very brightly. There it is, right there. Boom. Alright, let me show you. Okay, let me zoom in. Here's the straight wall right there.
All right, are you back on the Skype view now?
Yeah, you can...
Yes, that's a straight wall.
Yep.
Rupes Recta.
Yep.
Uh,
I saw it earlier, and I just couldn't remember where it was.
yeah.
Let's see if we can do a quick... There we go.
Yep, that's it.
Yep.
The little thing at the top of the straight line of the straight wall,
Here?
yes, that is, when you get a good view of Rupes Recta, that looks like the handle of a sword, like the guard on a saber. And then
The hilt?
Yes, the hilt. And then you can see it there in that frozen view. What's at the top of that view, that's the handle of the sword. And then the dark line coming down is like the blade of the sword.
And then there's the blade, okay. So this looks like the handle and the hilt and the
Yeah.
blade. That's a big sword.
I read somewhere that it looks like a steep cliff. Actually, it's not.
Correct, yeah.
When the sun is coming from the upper left, as in this view, a sunrise view, it makes a dark line. After full, it will make a bright, broader line. It's actually not a cliff. It's just sort of a rise.
Steep ridge.
The difference between the left side and the right side of it's about 900 feet in elevation.
Yeah, you can... When we look at the... one of these nights we'll do the LRO Quick Map class again. And I'll show you... we can go to the straight wall here, to Rupes Recta. And we can draw a line right across here. And you'll see the higher elevation giving way to the lower elevation down here. And you actually see it. And you'll see that the slope of the hill... this here is not just a vertical drop. It's actually just a gradual slope. You could walk down it. You know, it's steep, but it's not at all untraversable. It's pretty cool.
Yeah. And the feature's correct name is Rupes Recta. Its casual name is the straight wall.
Right. Very cool.
That's one of my favorite features.
Yeah, that's beautiful.
So can you back out now and see where that is relative to Tycho?
Yeah, I can show you right here. There's Tycho.
Yeah.
And there it is.
Yeah.
Yep.
Okay.
And just so you can see, okay, notice this crater right here. Let's look, we'll move in just a little. you'll notice that it has a broken crater wall. That's because this crater probably was made before this area that we're looking at right here. This area was probably made later. It's very possible, but I see with this rim being intact here, it seems to imply that, you know, this may have happened and then this happened, but then the wall was broken and the lava intermingled. So this helps you figure out when, in chronological order, things might have happened. This may have happened soon after or soon or just before. Most likely just after this happened. And so these types of features help with that. Help us figure that stuff out. You know, and again, a complex crater whose central peak might have a remnant right there. This is a simple crater, just a depression, a bowl. And we'll notice when we look up close at these, especially in the LRO quick map when we do it, you'll see that these complex, or these craters, these simple craters, they're a bowl shape. They should have a perfectly round bottom, but in fact, they have a flat bottom. That's because with the impacts around these craters, like this one that occurred, this one that may have occurred, and others that may have occurred, the entire ground shakes and stuff falls down the crater walls and lands in the bottom. And over time, you get stuff building up, and it tends to seek its own level, and you get like a flat bottom to some of these simple craters. So they fill in that way as well. But very rarely do simple craters have lava in their bottom. They tend to just be bowl-shaped depressions carved out by a much smaller rock than the ones that created, say, this one or that one or this one with a central peak. You know, and we back out. In fact, when you look at the moon, you can see so many different crater sizes here. And let me just drop our exposure down a bit. You can see so many different crater sizes, so many different brightnesses. We call that albedo, okay, brightnesses. And that has to do with the amounts or the soils that are excavated when the meteor hits. Some of this stuff is lighter, okay, and so the stuff on the surface directly, that stuff is darkened by the constant UV and cosmic radiation that's striking the lunar crust. It makes things darker over time. And so when craters are excavated, the rays are always bright because that's stuff that has not been darkened in time. So that's why the moon has been around for billions of years, and some of these craters, have only been around for a billion years or a few 100 million. Okay, so their rays have not been darkened to blend in with the rest of the moon. Here's another low energy impact here. Here's Messier with his two, hop, skip, and a jump crater there. There's another one here that's caused here, and is that Kepler? I wonder if that's Kepler. I have a 3D print of Messier that I made. It's really pretty, and then Kepler.
You can see the general ray there.
Yeah.
Going back to Tycho out of field in the upper right.
Yeah, that's it, yeah.
And some of those, I would almost wonder if those aren't secondary craters from ejecta from Tycho.
It could be. I mean, that's why.
I see 3 or 4 craters in a rough row there, all bright.
Like right here and like right here, yeah.
And their rays are all going the same direction, and they're all leading back to Tycho.
Yeah. This one isn't quite leading back to Tycho. It's going kind of like that. A little bit. So this one may be a little different. Not sure. These are really directly going this way and arcing along the moon. Because remember, we're looking at a sphere. We're not looking at a flat screen, right? We're looking at a sphere.
Yeah.
So there's a strong possibility, and it's actually guaranteed, that some of these craters were made as secondary impacts from the primary impact.
Rocket City has a question. Rocket, you said, what's our thought on mineral moon images where people oversaturate to bring out colors? We talked about this in the last stream.
Yeah.
That we, looking at the moon, I mean, we could see subtle differences in shade and color in different areas, and people do that on purpose. They create some really lurid looking images of the moon, trying to bring the colors out. If I remember correctly, titanium shows blue, iron shows kind of brown or orange or reddish.
Yeah.
You can see a little blue right there in the lower half of that image right now, down toward the lower right about where your pointer is, Mark, in that area.
Well, we have a color difference here. We have a color difference here.
Yeah.
Right.
You've got a big blue area right there.
Yeah.
And the stuff above it is more of a brownish tint.
Yeah, brownish, reddish brown here and out here. Again, different types of lavas that created these areas, and different mineral content. Here, if you notice, it looks like a donut of color around a darker color in the middle. See that?
Oh.
Rocket City says, I like and hate it at the same time. I like it because the exaggerated colors illustrate the different elemental abundances on the moon. I don't like it because it's not accurate to what the eye sees. But
Right.
when the astronauts were there, and they were there, when the astronauts were there, they talked about seeing very, very bright orange soil in one particular case. And you got to wonder, where did orange soil come from? And so there's a whole process of understanding that surrounds where the orange soil on the moon came from. It's just really interesting science. Rocket City says, I push some saturation, but I try not to overdo it. And you can overdo it very easily. Yep. So Dean Bustador says, so oversaturating brings out true colors? Not always, but in many cases, you can get a better idea. For instance, if you look here, Dean, you can see saturation has to do with the colors, yes, but if you look here, okay, you see these colors, and it's different in here. This looks different. This is different. If you apply saturation to this whole area here and there, and this area right there, and then up in here, they'll all appear much more separated from each other. So the saturation may be very helpful for you to see the differences going on the moon, and you may not even imagine. And I don't blame you. You can't imagine how different the moon is and so forth until you actually do that kind of work. Now, here you see this area right here. Okay, there's a very, very sharp delineated area. This is different lavas in here. These are different lavas in here that made this versus what's here. This could have been an earlier lava, or most likely a later lava over this material here that might have been laid down earlier. The moon is extremely complex, and a lot of complex things happened on the moon. You know, let's try something here. Let's go right here.
I think that's a ray right across the middle.
Oh, that is indeed. It goes all the way to here.
Probably another ray from Tycho.
Yeah, maybe, huh? Let's do this. So look at that. That's nice. Yeah.
Kind of interesting oval right there to the left.
Right here?
Yeah.
Yeah, that's one of those nearly filled craters that suffered lots of complex strikes nearby, and it's almost gone because the lava has filled it all the way to the walls. So that means it's probably a very old crater, and then filled in later. Really cool. Let's see if I can pull down just enough to go up here. Yeah, that's really sharp in there, and you can actually get the crater edges and see some more detail in here. This is just this is called Gaussian wavelets, and I'm just playing with the different wavelet settings to get the best one for what we're doing. I think that's probably the best one. Oh yeah, look at that. That's really pretty. This, by the way, Plato here is 60 miles across. Okay, it's 60 miles across. All right, and what's interesting is when you look at the height of this sea that it's in, which is the Imbrium Basin, Mare Imbrium, okay, and you look at the height of Plato's structure here, you say, oh, well, see, this and this are at the same height. No, they're not. Plato has an elevated base, a bottom, compared to Mare Imbrium down here. And we'll see more of Mare Imbrium in the next day or so. When the moon is full, you lose all these shadows. And so it looks kind of washed out. You don't get to see much with a full moon, unfortunately. So what we do is we're going to we'll wait for the backside of the moon, and then we'll start imaging other things in the region, other beautiful nighttime objects. That's really pretty. We'll save that again. It's saving the whole picture, and I'll show you that. Okay, this is the image it's saving. Okay, so you can always zoom in and check out these areas that we're looking at. You know, Copernicus, look at that there. Copernicus shows up very nicely right there. Yeah, so this is neat. Really cool. Alright, so we'll go back to our live view here. The slight reddish color is just because I haven't I could bring this down just a little bit. It's a white balance issue. Okay. But if we were to then image a nebula, we would be losing red because we're losing some red here by doing this. Hi, Sherry. How are you? Nice to see you. Rocket City, by the way, I might have missed saying Heidi, and I apologize. This is cool. And this is our live view. Let's go up again and living along the Terminator is a lot of fun. But let's go up here to this area, way near the top, which is actually the bottom, South Pole. And let's bring this right about here, center this up. Okay, let's do this. All right, so now this is Lunar Highlands. This is a lot of elevated terrain here. We zoom in on it, you can see that the limb of the moon here is not at all flat. It's not at all that. It's just a lot of raised and lowered terrain here, which is really incredible. Let's see if we can sharpen this a little bit. Yeah, that's interesting. Okay, the other thing we can do, another thing that we have done in the past, especially looking at the moon, is we've done this. We've actually reversed and inverted the image so we can look at the rays as dark streaks, and it kind of makes the rays jump out a little bit more so you can see where they're coming from. Okay, so when we come back to that, if we take that off, you'll see that we have the beautiful view here of Tycho right here. Okay, and I can actually bring us down a little bit and up a little bit like this. And now if we invert this, you can see a little bit better these rays from Tycho. Alright, and we can, let's do this. Okay, so here's Tycho, and here's the rays. You can see them moving out. They show up very, very brightly. You can see subtle rays here as well. Hey Rogue, how you doing, man? Did he call you a sidekick?
He called somebody a sidekick. Rogue, this question came up the other night. The X on the moon, it's no longer visible. It's fully in sunlight. It's a lunar feature that you can only see for a few hours right when the Terminator passes over it.
Yeah, we saw it, I thought. But I didn't actually look for it directly, but somebody else in the chat said they saw the X tonight. That other night. Yeah. Oh, Jorge. That's Jorge. That's Rogue.
Okay.
Well, you were in the chat. Then you know that, Jorge, because the X was visible the other night. Okay. Really cool. Well, let's see.
Turned out space weather had a pretty good image of the X up a couple of nights ago, and I think that's what may have motivated people to mention it here.
I bet.
During the stream.
Okay. Okay, I'm going to just come on down. Actually, not here. I'm going to take us down here for tonight, just to do at least one more non-moon object right now. We'll come back to the moon if we want. But I haven't seen any satellites pass over the moon. You'll see a little tiny black dot moving across the moon, you know, and I haven't seen any so far. But they're not that common, but they're not that rare. So if you look for a black dot, see if it's moving. Like that's the edge of a crater rim, so that's not it. All right, but we'll come back to this. Let's take a trip over here, and let's see about getting to this nebula, which is kind of cool. Alright, so we're going to go to our 1 second view. Now we do have a moon out, obviously, so the moon is going to be obviously trickier to manage with our nighttime view here. We'll fit the width. That kind of looks like it. I'll have to do a longer exposure, but I have to bring up the gain too, because we've been at very low gain right now. Okay, this is the center of the Rosette Nebula, and I'm going to just do a 25-second exposure. But first, before I do that, I actually have to start up our guiding program. Very important to do that. We need to do that. So I will do this. I'm gonna go start up everything, connect all, and I'll move this over here, not too far, and let's get an image. Okay, and let's see if we can grab a star. Yeah, it hasn't. Okay, we got some stars. All right. Now I'm going to live stack these, and I'm going to dump that and clear the stack. So now we're going into our. Actually, to come out of this and do this again. I want to go in via our stacking process, our live stack routine. Let's see where this is. May not be able to guide, I'm not sure. We're going to give it a shot and see what it can do. Oh yeah. Alright, and we have to change our color value here to put that back to about 79 because it's skewing our color values. I believe. So let's do this. There we go. Alright, you'll see what the moon is doing here. The moon is actually causing there to be some extraneous light in here. But it's okay, because I just want to get a few shots here to show you. And I'm going to move our midline. Go away. Don't do that. Move our midline away here. So we can do that. And then darken up our background. So this is the Rosette Nebula core, and these are the stars in the Rosette Nebula. Rosette Nebula is over just about 5,000 light years away, and it really is a beautiful sight. Now we constantly have to color correct because the lunar proximity, the proximity of the moon, causes the camera to have color response issues, but you'll see the curves are aligning better with each other, and that's kind of what we're looking for. This white curve is the additive result of the red, the green, and the blue curve. All right. This beautiful feature right here in the middle, this guy is a interesting nebula in the center, and the rest of this stuff in here is beautiful as well. But it is a white nebula. It looks like white, but it's gonna be some type of elemental glow, probably caused by oxygen in the middle here. So it's kind of hard to figure that out. I have to look for studies on the Rosette Nebula to show that. But this is beautiful, and the stars seem to be guiding. I'm going to unstack this last one because I think it missed something. Let me come back here. Yeah, it stopped guiding properly, so let's redo that. Have it reacquire stars. And start guiding on them. Okay. Unstack that last one. Okay, so now we have 6 here that have been stacked. And this is our full width half maximum filter. It's really a test. I want to just do the inside here of the Rosette as a test. And we're going to call it Rosette Nebula Core.
Mark, excuse me a moment, please.
Sure thing.
Thanks. I'll be right back.
Okay. Okay. Oh yeah, make sure to join the group's chat too. Thank you, Izabela. That's a very good thing to do. Okay. Because what we want to do is make sure that everybody who sees us here in our chats can also come to us in our YouTube or Facebook chat as well. So right now, while we're doing this, I mean, over in Wickenburg, 200 miles away, is the moon here as we see it. Okay, and that actually looks pretty cool here. Not bad, actually. Yeah, we're still actually doing some nice shots of the moon here. And I'm going to actually change this here and say moon as well. And we'll say Sonoran. And let's take a snapshot. That's cool. All right. And then back over in Benson, we're imaging the Rosette Nebula. That's really cool. And let's see. Let's go back to our histogram. And notice our color curves are doing far better. Because as we get in more data, that actually helps. I notice a little elongation here on the stars. But we are having a little bit of wind out there that we're dealing with. So let's see here. The other thing I have to do is I've got to do dark frames for this. And that means someone has to go out there and help me with the dark frames. They got to cover the end of the telescope while I do dark frames for this camera. That will actually allow us to do a better, have a better acquisition rate for stars in the field, so that we can capture them the way we want. Now, let me try something while I'm here. Okay. Let's unstack. Did a little bit of unstacking, okay. And Daryl's back.
Yep.
Okie doke. Okay. All right, so that's really nice. So this nebula is the thing I was sort of after. I wanted to actually get a better view of this. We could enhance this a little bit by increasing our unsharp masking here. Yeah. Okay, that's good. And we could do this too. Okay, so now you can actually see our guiding screen and the result screen. But this is the coolest thing. You know what's funny is in the other telescope, in the Wickenburg telescope, when we look at this object, this is not as obvious. Okay, and I'll show you what I mean, because okay, we're gonna go from here. We're going to go now to that object in the Wickenburg scope as well. That is, I say Wickenburg, it's not in Wickenburg, it's just, that's the nearest town to us. Okay. So what I'll do is I'm going to take us over to that object here as well. And I'll bring us there now. Okay, and we're going to go back to the 1 second, which is our methodology. The gain is low. We're going to raise the gain tremendously up to 220 or so. There is the center of the cluster. And we'll normalize here, which is good. And so now I'm going to move us a little bit to the west to do this. Okay. And raise us up a little bit. Alright, so we're going to raise up and move us a little bit to the west again. I'm going to center the cluster, in other words, because by centering the cluster, you'll see the overall view that you get with this particular scope in Wickenburg, in the Sonoran, which is where it is actually. But before I do that, though, one thing I'm going to do is I'm going to focus, because we need to focus the stars and get that taken care of. Getting the focus is very important because we need to have that critical focus. All right, and that's going to be just, you'll notice they look like little donuts. That's what happens when you actually have a Schmidt-Cassegrain telescope like this, and it's out of focus. So now we're going to start scanning in the negative direction. We're going to build a curve, and it will have a perfect focus curve. So let's go back to Benson right now and see what's happening over there. Okay, so here we can check this out now. Let's zoom in a little. Okay, we can see this beautiful image coming through. This is really nice, Daryl. Let's again, with the moon like this, it's hard to actually get a good image, because see the blue. That blue is artificial. It's created by the moonlight, but we're using a special filter, or we would not have gotten any of this. If we went to, this is our filter wheel down here. We have what's called a radian filter, UHCS, which is our old workhorse. SA100, that's a a spectroscopic gradient filter. Then we have a dark filter that's just black, so we can actually do our dark frames. And we have open, where there's no filter at all. And so sometimes that's helpful as well. But right now, we're looking at this. Let's go back and... Okay. All right. So meanwhile, over in the Sonoran telescope, we have our focus curve, as you can see. And the telescope is going to... I'll just send it to best focus because I didn't want to make it wait. You'll see the stars go to nice pinpoints. There we go. There they go, nice pinpoints. And now we cut out of that, and now we can take our exposure, and we'll take the exposure of 25 seconds. Okay. And we'll remove our low light mode and go into deep sky mode. And we'll come back after this commercial break. I was kidding. Right. Over here now, we can see we are up to 26 shots with only 4 that have been rejected. So that's pretty good. And I want you to see this guy right here, and we're going to check that out. All right. In the other image that's going to be coming up. All right. All right. And that, what we're going to do there is figure out, when we look at this, we're going to figure out just what differences we're seeing between the two telescopes in terms of detail. Remember, the telescope out in the Sonoran is cutting my head off here. The telescope in the Sonoran is actually a wide field system. All right, and the telescope in the Benson Plateau area is a narrow field system. So what you're seeing here is very narrow field. What you're seeing here, okay, is a wide field. And that area we're looking at was right here. That area with the white nebula in it is right here. Okay, in there, that's the nebula region we're looking in. So when we come back, okay, you can actually see this region that we're looking in right here has a lot more detail in it. But we give it some time and you'll see it come in. Very cool. It's actually a very pretty region. We can zoom in more on this now and pull it up. So you see the filamentary nature of this now. It has a lot of filaments and additional detail in here. This stuff is the stuff we need a higher focal length system for, like we have here. If we use the low focal length, the wide field system, well, we have to zoom in so far that it would get kind of pixelated and look kind of grainy, and that's the problem. We don't want that. You know. Alicia's with us. Alicia, howdy. I missed you coming in. Alicia is by now out in Mesa at Marianne's house. At least I think you are, unless you're still in the car. As I believe you, your mom, and Darlene went to Marianne's house for a few days. Yeah, I'm finally at Marianne. She said, oh, okay, fantastic. Darlene is her 10-year-old daughter who I gave her one of my books, The Populated Universe. And someday she'll finish it. I know she will. Okay, let's go check this out now. Here is the other view. So you see the detail here is not as striking, but we get more detail in the overall view. And I'm gonna take this back a little bit. Oh yeah. Let me come in here now and just take this back a little bit to kind of soften things and allow you to see. Let me zoom in. Let's try and zoom into the same level. Okay. Zooming into the same level here, that's an artifact, okay? Yeah, we have some noise, as you can see. And that noise, obviously, we have to get rid of much of that noise. So I'm going to get rid of the color noise right now. Okay. And we'll turn on the unsharp mask here and sharpen up detail as best we can. And you can see that it's not really helping yet. But then again, we only have 9 stacked here. We don't have more. But you see the problem that we're facing, right? We actually have a system that is beautiful at getting a lot of data with a wide field. And that is great when we're looking at giant nebulae. But it's not so great when we're trying to look at details, because closing in on details is what this other scope here is better at, you know? And now this is looking so nice. Let's see if we can bring out some more detail in it. Pull that in. Look at that. That's pretty, Daryl.
Uh-huh.
And then in the enhancement, let's see if we can actually pull more detail out here. Yeah, very nice. So that is a really, really nice image. I'm going to save that. It's we're going on 40 images here. And this next one should be the 40th. Excellent. So we'll save it now. Save exactly as seen. We've only lost 4 to wind, which is nice. All right. So that's cool. And on the other side, we have a few more to acquire. We're at 13 here. But we will actually save it along the way here as well. All these images are yours to take and bring down and look at. If you just go here, go to skytourlive.org. You can scroll down until you see Take Me to Cool Pictures and get some really, really cool pictures. And please, as Daryl says, hit that like button, because it helps us with the algorithm with YouTube and Rumble, if you're watching on Rumble, or Twitch or Trovo. And we're going to be going to other platforms as well, in addition to the ones we're already on. But it's going to take us a little time, because I'm pretty much the only one that does it. I'd really love to have a person that can handle our social media. I need a good social media director, and someone that can help us with all that stuff, because that's really important, and I can't do everything. Marianne can't do everything, in fact, Marianne doesn't know a lot about the social media side of things. So, so I think it's pretty cool. Dean Bosdor says, I use the app which comes with 2 cameras, AutoStacker 3, Registack 6, but then I mainly do planetary imaging. That's cool, yeah. Registax is good for that. PIP is good for that too.
I think he says ZWO cameras.
Yeah, the app. Okay, I see what you're saying. Yeah, use the app that comes with ZWO cameras. Yes. AutoStacker comes with it in Registax. Wow. All right, that's cool. Let's head back to Benson and see what we got over there. Yeah, this is looking pretty. I'm gonna see if we can pull a little more detail out of this. Yeah, that's pretty. Okay, let's Hey, Jerry Darby. How you doing out at River's Edge? Nice to see you. Wow, okay, we'll save this one more time. Save exactly as seen. And we'll head over to...
Before you leave,
Yeah, I'm not going to leave yet, but go ahead, yeah. What would you like to do?
looking at the image you have up in Skype right now,
Yeah.
over about halfway to the left, near the bottom, right there, I see a dark figure 8. Is that an artifact or is that something real?
In here?
Yeah.
Let's zoom in and see.
It's like a dark cloud, but it's like a figure 8. It's a little more than half the height of the screen right now. Do you see that?
This here?
Yes.
Yeah, I wonder, because we can check that by going to...
Dean says he sees it too.
Yeah. Let's go look at the Sonoran view and see if we can see that figure 8. It would be down here. Right in here. Ooh, what happened there?
That one Midland bright star is like very near the...
What?
The one middling bright star to the lower left, right there, that bright star, looks like it's right about where the two legs of the 8 cross.
Let's go see what you mean. Okay.
Izabela and Django say dust on the camera.
This? No,
That's what they say.
Yeah, we don't have a figure 8 dust on the camera for sure. Let me take the enhancement off here, the stacking of that, rather the enhancement. That sort of changes things a little bit. This looks like a dust cloud right here. And we have dark dust clouds in here. That's just to the left, huh? Let's go look here. So here's the thing, just to the left. What are you looking at? Let's zoom in. Well, we do have complexity in the hydrogen alpha clouds in here. The ionized hydrogen. You know. So interesting that it looks that way. Izabela thinks it's an artifact. I'm not sure about that. Let me color correct this. With color correction, does that do anything for us? Interesting.
I've never noticed that before.
Yeah, well, I'm zoomed in. Like, this is our other machine here. I'm sorry. This is the Sonoran telescope, and I've not seen it before. But then again, with a Sonoran telescope, we'd miss it. Let's do this. Let's bring that in and zoom in a little bit.
You do see what I'm talking about, don't you?
Yeah, I mean, we looked at it with the other one. And with this view here from Benson, you could see this subtle shape right here is what you're talking about, correct?
Your pointer is off to the right of it, but yes.
Or are you seeing something here?
Right there. That bright star that your pointer is orbiting,
Right here?
that is, yes, that is right in the middle of the figure 8.
Oh. And you're seeing the rest of the 8 down here?
Half of the 8 below it and half of the 8 above it.
Okay.
That bright star is maybe just a smidge to the left of the center of the 8.
Okay, so if we zoom out of this,
Still see it.
okay, and it's on a slight angle, or is it straight up and down?
It's pretty much straight up and down.
Huh.
2 loops tied together in the middle, and that bright star is very close to the middle.
Hmm.
You don't see that.
Well, let me,
I don't see it now.
I know,
Barely.
I know, it's hang with me, slow down. Okay, now, let's see if we can decide where it starts to show up.
Whatever you did, it went away.
Yeah, so what I did was I have this off the peak. So if I bring this onto the peak and close,
There it is. Just below center now.
this guy, that's the star you're
Yes.
talking about?
Yes.
Okay.
Now, as you adjusted your black level, I mean, it did come back and appear.
I mean, I see this. Is this what you're talking about?
Uh-huh.
Yeah, I see that. But I'm wondering if it's the brain completing the 8, and it might be just some dark nebula in here, and that's why I wanted to go look at the other telescope and see in there.
Not just my brain, a bunch of people saw it.
Yeah, I mean that's, but yeah, I wonder if it's. I'm just wondering if it's a pareidolia effect.
I don't think that's pareidolia.
Well, I don't see it in the Sonoran view, but maybe if I alter the contrast a little. Let me color correct that. I don't see it in this view, the Sonoran view. But back to Benson, I did see it. So, yeah. Okay, well, we'll save this here anyway so we can examine that later as well. Okay, and then we'll, do the same for the other image as well. Very nice.
Well, at least, I mean, it's not me having hullabalootions. A bunch of people saw it, see it now.
Oh, no, I'm not saying that. Oh, I see this. I'm seeing that now. And this.
Yeah.
It's standing out now. Okay. I'm going to go take back what I said when I suggested to Izabela that it may not have been an artifact. I can see these donuts. And those donuts might actually be I've seen those before when I was looking in a blue sky and doing a high contrast view. And I think that you might be right. It might be dust on the... Yeah, there they are. See the two donuts?
Yeah.
Yeah, those are dust on there as well. And so we're going to be sending this camera out to be cleaned. But I'm also going to be getting another camera for this telescope. One that actually is a little bit better. I also have potentially another scope coming in here to join and make it a third scope, and it's going to have a spectrograph on it, so we can actually truly study the stars and their composition. So we'll be able to do real science with that as well. Okay, now I definitely see the donuts. That's those are the sensor has some issues. I tried to clean it. Terra Deulus, tried to clean it rather extensively several times, and they never went away. I think it's something internal, and I think I have to send the camera to ZWO and have them clean it. You know, Star Arizona can't get in there either. They can't go in there and clean it, as far as I can tell. And I don't want to start taking apart the sensor, because as soon as you break those seals, all bets are off. Okay.
Well, at least I'm not hallucinating.
Not at all. Not at all. Once I was able to bring this up and really do that, you can see the round donut. And there's more than two actually in the view. There's several others at various spots. And for some reason, the moon makes us have to use higher contrast. And when we do that, that's when they seem to show up. You know? But alright, anyway, okay, so let's we save this, so we're gonna come out now and go back to our 1 second shot here. Let me just go up here. Here we are. Go back to our low light view and times 23:47 hours. We're good. Okay, here's a low light view. Boom. And we'll go back to fitting the width of the sensor. That's really a wide sensor, so it's quite crazy. I didn't remember just how wide the sensor was on this. Okay, and then let's go back to the other one. Okay, and we save this one as well. It's already been saved. So, and that's actually the zoomed in version. Zooming out, the entire nebula is visible. Okay, and now we'll come back here and go to our low light mode as well. Right there. Let's go back now and look from where we are here. This is the Rosette. Let's now think about jumping back to the moon. Alright, so let's do that. We'll go back with this telescope. And there's the telescope moving up to the moon again. Yeah, it's a bright one. There it is. Alright. And we're going to drop this down to 50 milliseconds. And drop it down some more. The Benson 8.
Yeah. Daisy and Zoe called it that.
That's cool. Yeah, Daisy and Zoe, that's pretty funny. That's kind of like the Lunar X, the Benson 8. That's neat. Okay, let's bring this down, get into the view, get back on lunar tracking here. Okay. And go west. I know you're not seeing this yet, Terrell.
I think somebody was eating a snack when they worked on the camera.
Nope. No, nobody in our circle was eating any snacks.
I'm joking.
Okay, there we go. And now let's go back to our Benson's view and let's get out of this. And let's jump over to this guy and let's go look at the moon again. I guess we could try looking at Mars too. We should try that.
Pretty small.
Yeah, it is. So let's just see. There it is. And we'll immediately come out of here and drop down to 0. It's small for sure. Definitely the red planet. I'm going to call Starzona and see what they have for an ETA on the field rotator. Okay.
Say that again.
I'm going to call Starzona and see where the ETA is on the field rotator.
Oh.
Okay, let's do 35 milliseconds on this, just to get a start point. There we go. Alright, let's zoom in now. It is small. Let's see if this shows us anything. Oh, look at that. We see some detail. You see it? Well, I did. Yeah, I saw some initial details that were actually pretty nice.
Why does the red separate like that?
I'm not sure why that's doing that. It might be a reflection on the of the filter. I bet you if I did this, I'm gonna try something a little different. I'm gonna go to open. I'm gonna take out the filters. So now it's just going to be an open view. Okay, and we may have to refocus because the filters change focus. And so let me just, we're going to have to reduce the brightness too. Let's see. All right, I'm going to test if it was the filters by coming in because I got no filter now. We're looking just through the open. All right, so it's not the filter. It's got to be I mean, we're seeing detail on the surface, but it's just fleeting because we're getting this problem here. Okay, let's. Yeah, it looks like we need to focus as well. So let's try that. Let's we are looking at a very small object, so aerosols and turbulent aerosols will cause some pretty good disturbance to this. Let's try to go positive with this for a bit, see if that helps. Maybe, not sure. Do it again. And try and do this now. Interesting. I haven't. I've only seen this happen when the moon is out. I haven't seen it happen before. I got beautiful shots of Jupiter with no moon out, and we saw all the cloud bands on Jupiter. You saw them. But when the moon is out, for some reason, it looks like we're getting some secondary reflections. I wonder if they're reflections off the corrector plate. The red is a shift in wavelength, and the wavelength shift could be because we're getting a reflection internally from the corrector, possibly. And of course, it's not good here.
From the moon?
Yeah.
I would think the dew shield would stop that.
Well,
that's one of the things it's for.
Yeah, but the moon is right near
off-axis light.
Huh?
Off-axis light.
Well, yeah, but we are actually right now. We are actually sitting with the moon in full view of the corrector.
That's true.
All right, let me. We can see some detail on the surface here, small as it is. Let's see if we can get this to show something. Yeah, it's like if I change a value, it just momentarily shifts back.
Oh well.
Yeah. Okay, well, you can see the wind is blowing it around too, so and the turbulent air cells make it hard. But you see, it looks like Syrtis Major in here, possibly, or maybe one of the other locations on Mars. We can normally see the polar caps, at least one of the polar caps, but not tonight. All right, it's not still enough night for this, but that's all right. We gave it a shot.
Go back to the moon.
Yeah, we'll go back to the moon. And I was sitting at 250% on the sensor too. All right. Now we're going to go up to the moon again. There we go. All right. That's very close, as you can see. Notice the reddish color of the moon. That's because the color shift I had to change. My sensor is running at minus 19.8 Celsius. So it's actually a very nice and chill sensor. Okay, let's take this down to 60 and give us our proper coloration. And then we'll zoom in a little. Let's go look at increasing our exposure a little bit. As we increase it, Rupes Recta comes in a little better. There it is. Interesting, there's a ray, it looks like, of this crater that kind of goes over Rupes Recta. I wonder if that's an actual thing going on or not. Let's do this. Oh yeah, look at that. Okay. Okay, well I saved that as that.
The straight wall.
You got it. Now, as the night goes on, You probably didn't notice, but the shadow on Clavius was changing ever so slightly.
Yeah.
And I do want to actually take a snapshot of that so we can
Looks
do
like
comparisons.
the largest crater in the row, the one at the top edge of Clavius, looks like it has a little peak in the middle of it.
It does. It does indeed. I'm going to see if we can get a nice shot of this here. Okay. Save that. Oh, I did it again. I didn't rename where it's going. I should have named that back to being the moon again. My mistake.
Dean, it looks like a crater to me.
Yeah, Dean, Amaria can be created by a meteor. So Amaria, in many cases, is a giant crater that's been filled with lava from the internal breakage and fissures that form from major impacts. So, yes. So if we actually let's zoom out a bit here. No, okay. When we look at this mare right here, that was a giant crater impact. This was a crater impact, a meteorite impact. This was definitely a meteorite impact. It's pretty obvious. Okay. And then if we if we go down here, Mare Crisium, a very clear meteor impact with overfilling of the surrounding terrain. And then moving down even more, we'll see it better tomorrow or day after. But in Mare Imbrium, the Imbrium Basin is right here. You can see the circularity. This was an absolutely colossal impact on the moon. This was a colossal impact, the one I'm telling you about. There's a lot. The mares can be impact features, but Clavius is actually small enough that it probably isn't. In fact, that it's definitely not, I should say, a mare, one of the Marias. The features of the Marias are that they have that darker lavas that overfill and overflood them, and we don't have that with Clavius.
Michael H. has a question of you.
Okay, Michael H. That's Michael Hedrick. I know him. What does he want? He says, I've been studying ancient cultures. Are there any Native American histories which you have come across lately that speak of the stars? Oh, very interesting. Yes, Michael, there are a great deal of them. And you're going to ask me what they are right offhand, and I can't tell you. But I do know them. I actually did a talk on them. And I have to go back and get my notes on that. One second. Hold on. I'll be right back. I'm just going to grab something. on, I'm looking for something to show you. Alright, hang on, I'll be right back. I know where it is.
Sorry, Mike, not tonight. When you look at cultural myths around the world involving the sky and objects in the sky,
Okay, I got it.
you see a lot of
I had wanted to show you. I had wanted to show you when I talked about the 3D printing of the craters. I wanted to actually show you what they look like. So I'm going to do that. I just have to see if I can show you with this. Let's move this here. Yeah, we can. Okay. Let's see if this works. Alright, so right now, this is Clavius. That's the print of Clavius. You can see the crater Daryl was talking about. Okay, right here, the big crater with that central peak. Right? And you can see how there's a chain of craters going into the middle. You can see the whole structure of Clavius in there. This is about let's say a 1/4 inch thick. And then the back side, we print the actual details right into the piece for each of the craters, so you can see. So that's what we do for people that want to have really cool really cool samples of a lunar crater. If they have a favorite crater, we can and often will create them for them, and they can just enjoy them, and it's kind of cool. All right, let me get myself out of the way here. There we go. So there, that gives you an idea. Okay, Marianne, you and Darlene drove by my hospital. Okay, great, and you saw my wing. Excellent. Did Darlene have to go to the hospital? Or are you just trying to bust me in front of everybody watching? The answer is she's busting me. Okay, hi Darlene. How are you? Nice to see you at Marianne's. Glad you made it. Darlene and her mom drove, along with Alicia's mom, Renee, drove out to Arizona from Texas. That's quite a drive. Moon's looking better right now, actually. So there's Clavius crater. Nice. Oh, he just drove by. He took her to Chick-fil-A. Chick-fil-A. Okay. Yeah, so this is really looking nice. Again, I haven't seen any objects passing in front of the moon. But obviously, we would just have to let it sit and, not do much, right? Because we would actually want to see if something's passing in front of the moon. So when we stop, you look really carefully and see if there's a little black dot moving across the moon. And now there's the terminator, so it's going to be moving probably one way or the other. Mostly from our perspective, it's probably going to be going this way.
Yes. West to east.
Yeah, because we're actually, the moon's upside down here, because of the way we're looking at it, and because we don't have the field rotator.
Dean Bossador asks, okay, Mark, Daryl got to ask, what are your thoughts on TLP?
That's transient lunar phenomena. You talked about it the other night, didn't you?
A little bit.
Yeah.
They happen, Dean. There are a variety of different transient lunar phenomena. I don't remember them all right offhand. Gas releases of gas is one. We mentioned the other night that we talked about the crater Aristarchus, which we're going to look at in the near future, hopefully, when it's illuminated. Aristarchus is the hot spot on the moon for transient lunar phenomena. There's a number of areas on the moon that are known for TLPs, and Aristarchus is like number one of all of them. One I've been curious about, they mentioned with the Blue Ghost lander by Firefly on the moon, they hope to see dust levitating on the moon at when the sun sets for the Blue Ghost.
Mm-hmm.
There's a thing sometimes, electrostatic charge or something evidently makes lunar dust levitate off the surface. That would be interesting to see.
Yeah. I'm going to try something right now. I'm going to try to overexpose and see if I can see. It's kind of tough. It's harder when the moon starts approaching full, but we could give it a shot here. We're going to try it. Let's do a second. This will be very, very bright, and well, we can see the edge of the moon right here. And what I want to try and do is see if we can see Aristarchus, because we can see it in the Earth, the Earth glow. Normally, as you can see, on the limb of the moon here, there's a star out here. Here's the limb of the moon right here. You can kind of just see it. But as the moon approaches full, it's harder to see the unlit side yet. Okay. I don't see Aristarchus now. I think it's lost in the glare.
Yeah.
But it's right about here. It's probably very, very close to being visible. It's just near Plato. Not near Plato. It's it's over. It's like right here, just about here. Yeah, right about there. So we have to really overexpose to see it, and it's too bright over here. But by the way, that points out something that is just proof of the fallacy that, the astronauts were in a studio because you couldn't see the stars. Well, you couldn't either, and you can't right now. When we expose this for looking at the moon to see it normal like this, you can't see any of the stars. All right? We move out and there's no stars. You don't see the stars out here. Okay, the only way you see the stars is if you overexpose the moon drastically. And it's the same thing when you're on the moon. To photograph the moon normally, you've got to lower your you got to raise your f-stops, right, to shut down the iris of the camera, and then you can actually capture stuff that's on the moon, but that's going to necessarily preclude stars from showing up. So that's why the lunar sky was nearly always black from the astronaut's perspective, okay, with all their photography. And it's because the stars were just much fainter than the brightness of the moon. And nowhere do you see it more than when I just did that little thing where you can see the star out there. You can't see that star now. You know, if we increase this and even brighten this up, okay, like really, really high, okay, you can't see the star. Let me actually do that. Okay, you can't see the star out here even now, and the moon is way overexposed. You have to lower the exposure to record the moon correctly. Okay, so when you record the moon correctly, you're losing your stars, and that's always going to be the case. Alright, so we'll just bring this down now slowly.
I think you could say some of that is the dynamic range of the human eye versus that of a camera too, though.
It is. You know, the camera has a very stark eye. It only sees a narrow range. The human eye, if they shielded the moon, then their pupils will dilate a little and they could actually see potentially the brighter stars. Keep in mind they were wearing gold visors too to keep the ultraviolet radiation off their retinas, so and away from their skin. So they actually had to use the gold visors much of the time they were up on the moon. And if they raised it and they could just see through the glass directly, well then, you know, in the shadow of the lunar module they could look the other way from the sun and probably see a glorious starry sky as long as they blocked out the moon and let their eyes adjust. But in those suits they were wearing, the space suits, they were like the early diving suits. They're very cumbersome to wear, and mobility was not the strong suit. Plus, the lunar soil was basically sharp pieces of glass. Each of the particles was actually exceedingly sharp, had jagged edges, and over several space EVAs, extravehicular activities, they actually found that the spacesuits around the cuffs of the ankles were being cut through all the way to the insulation by the sharp nature of the lunar dust. And, you know, when the astronauts got into the lunar module, well, guess what? They're breathing that dust too. And, you know, they had to be careful about lung ailments. They could get coal miner's lung. They couldn't get coal miner's lung from that dust if they breathed in a lot of it. And I'm not sure if they had any pulmonary issues. That's a question for Amy Teitel, who is my favorite Apollo historian.
It's called silicovolcanoconiosis.
You know about it because of your mining experience.
Yeah.
Yeah.
The longest word in the English language is, or used to be, pneumonohydroxy ultramicroscopic silicovolcanoconiosis. all one word strung together.
The longest word is supercalifragilisticexpialidocious. And if you make me say it again, it's really quite atrocious. Neat. I am unaware of that long word. I guess if from your background you would know it, I guess, huh?
I think I knew the word before I ever went underground.
Yeah. Probably because you wanted to avoid it like the plague. Here's something interesting. When we started tonight, over here, I noticed that this rim was not lit up like this. It's actually lit up brighter now. It's kind of neat. And Rupes Recta should be right here. I don't know why we don't see it now.
It's just to the left of your pointer.
Yeah, it was right here.
To the left.
Oh, it's
That
over
straight-
there. Duh.
That straight line.
Yeah, okay. That's right, I missed it. I have a blind spot in my vision, so if I look at this crater, I can't see what's here. So it's just a fallout from surgery I had years ago that went haywire. All right, yeah, so this looks good. I'm happy with the way the telescope's performing. I would very much like to, get this on a night without a lot of, turbulence in the air. That'd be great. Oh, I see you put pneumohydroxy ultramicroscopic silica volcaniosis in the chat.
Volcanoconiosis.
Volcanoconiosis, okay.
I think I spelled it right.
Well, the fact that you took a stab at it means you get an A+ for effort. All right. Let's see. Does anybody in the chat have any other questions?
Michael had one about halfway up the chat box right now. Are mountains on the moon all from impacts?
Oh, no. But there has been in the early time on the moon, there was some seismic activity that could cause some mountains, but the vast majority are indeed from impacts. The highest spot on the moon is from a major impact that's on the far side, and it's the result of the impact that made the lowest spot on the moon, the Aitken Basin on the far side of the moon. The highest spot on the moon is way north of that by, at least, I'd say maybe 800 miles, 850 miles north of that basin from the lowest spot. The highest spot is up on a raised area. But the other reason that we have the far side is where the highest spot is, and there's a reason for that. That's because the thickest crust on the moon is on the far side, not on the near side. On the far side, we don't have Maria. We don't have these gray areas like this, like we have on the near side. And the reason for that is because in the early days when the moon was formed, it was semi-molten, semi-solid. And so whenever there was an impact that would drive up lots of material around the moon, the cooling Earth, which had a lot of heat being generated, was generating this heat, obviously in the form of infrared energy, and that has what we call a radiation pressure. And that radiation pressure is theorized to be in the amount that could drive the material further away from where it was up in the area around the moon, up in the sky around the moon, so to speak, and push it to the far side where it would fall on the far side, making the far side thicker. The far side is almost exclusively craters, except for Mare Moscoviense, which is a small Maria, which is very, very tiny, and of course Tchaikovsky crater, which has a Maria inside of it, kind of, sort of. It's basically the only two cratered areas that have Maria-like features. So So that.
Uh,
Go ahead.
Unsurprisingly, they also all have Russian names
Yeah.
because the Russians found them first.
Yep. And they get the first right of naming. Yeah. So that's why there's no Maria on the far side of the moon to speak. To speak of. We have these. Obviously, the front side of the moon has all this stuff because the crust was thinner, and so impacts tended to bring up magma from inside the moon, which flowed as lava across the surface to make these Maria. The far side, the only impacts that could actually do that were impacts that were absolutely stupendously colossal. And one such impact was the Aitken Basin. That's Aitken, Aitken Basin impact on the far side in the southern hemisphere of the moon. And it is very, very large, has many shock rings of impact. And when that happened, it pushed out so much material that it pushed mountains up all around it, including the highest location on the moon that I was just talking about. All right, but the early moon was formed, and when that infrared energy pushed that material to the other side, it did thicken that far side and make mountainous regions on the far side. But they were typically more uniform because it was a uniform distribution of material that was being pushed to the far side. So there were localized areas of high and lows, but then the impacts actually made the walls of the craters drove those different heights that we see as in this very image. Hopefully that was clear and not mud.
One thing about mountains on the moon, people often have a misconception of is they think they're big, jagged, pointy mountain peaks, and they're mostly not. There was an artist named Chesley Bonestell Bonestell, who did a lot of space paintings of the moon and the planets, and he liked putting big, jagged mountains in his paintings. And a lot of people to this day think that's what mountains on other planetary objects or moons look like. A lot of that actually came from when we look at the moon and we see the shadow of a mountain on the moon. It's real long and thin and spiky and peaky looking, and just because of the sun angle, like during a sunrise or a sunset, that you'll see a mountain in the middle of a crater, and the shadow side of it is a real long pointy shadow. And people thought that's why, because mountains are big and long and peaky looking. And it's just more of a horizon effect that
we call it raking light.
Yeah. You see that here in Colorado, that at sunrise or sunset, the mountain peaks cast their shadows, and those shadows go a real long ways across the plain. That's no reflection of how high the mountain really is. It's just because the shadow is so long at sunrise or sunset.
Yeah, it's a sun elevation phenomenon. Out in the desert, I was running my drone out there, helping someone find water on their property. We found it. And at sunrise, the sun was rising across a mountain that was on the eastern side, and the entire region was blanketed in the shadow. And you could see from the air, you could see the long peak of this mountain being exaggerated far, far, far into the west. And the mountain was only about 500 feet high. Not even a mountain, it was a hill. Maybe 600 feet at the most. And but it is made to look so much bigger because of that. exaggerated shadow. Now, if you saw that from the sky and didn't know what Earth looked like, you could say, wow, that's got to be a giant spike of a mountain. But it's not. And as Daryl said, they're all rounded and soft. There's been so many impacts that many of the areas that look sharp and craggy on the moon are actually soft and worn in, because over time, large impacts threw up a lot of dust around the moon and other stuff, and that came back and settled down on the areas, and it softened a lot of areas. Yes, when they're first made, they're very craggy, but other impacts later caused the rims of very sharp-edged craters to collapse and fold over themselves, and the material would fall into the crater, and so everything is rounded and flattened off that way.
Point out Tycho for Michael. He wants to see Tycho crater.
Right there.
Yep.
We'll zoom in on it for you, Michael. That's right, you joined us late. There's Tycho, and you're looking at the air turbulence between here and the top of the atmosphere. In Benson right now, it's actually a turbulent sky. Has been for about a week now. So actually during this entire lunar apparition. But if we stack this, we can freeze all that and kind of give you an interesting view. So there you go. Here's a frozen image of Tycho crater right there. We could invert it and you can see the ray structure better. Okay.
I have to guess that the desert environment in Benson, Arizona is similar to southwestern New Mexico. And I know that's windy season in New Mexico.
Yeah.
So I assume it's windy season. Well, you said yourself it's always windy in Benson.
Well, at the moment it is, yeah. I don't know how it is the rest of the year. Weather Underground seems to think that it's not windy for a good deal of time. But, you know, I do know that the seeing is quite good much of the time. I just happen to be looking right now at a very turbulent time.
Yeah.
Most of the time in Benson, you wouldn't see any movement to the moon like this. And those days are coming back. I will say this. I've never been interested in the moon because I didn't have an instrument that could actually do it justice. Okay, this guy here, and I'm showing the other observatory right now briefly. This guy here can only see the moon at this size, right? But if we zoom in, you're going to see that the moon is also doing that same type of thing, right? With the air, with the turbulence in the air. You know, the image is going to dance a little bit, and you can see it doing it right now, right? But it's a wide field system. We don't have the same kind of, we're getting artifacts from here. They'll go away in a second. We don't see that same kind of thing out here in Benson. Okay, we have a more higher focal length system, so the turbulence is exacerbated and made worse, obviously. But it's still fun. So let's back out of here for a minute. So we're looking here, we're almost looking straight up. Okay. Let's go. It's Capellar. Yeah, the moon is too big to show this very well. That's okay. Alright, we'll stick with the moon tonight. We did a little bit of the Rosette. So this is really nice. This it doesn't look bad, I gotta say. It doesn't look bad. Goblin, thank you for coming out. Hey Toner Low, how are you? I just saw you said hello there, Toner. I apologize. Okay. Yeah, Moon is dancing in the streets. Look at the-
Izabela, I have a question of you. When do you go on, you might call it summertime, daylight savings time here in the U.S.? We switched tonight, 2 a.m.
yeah.
Do you not change for a week or 2 or 3 yet?
Mr. Django just finished his 4th SkyTour live stream mug of coffee. Your 4th? Wow. She says right.
A lot of coffee.
I know, Steven. That's a lot of coffee.
Excuse me again, please.
Yeah. Isabel
that?
says end of the month.
And we change later tonight.
Yeah, as Daryl said, 2 a.m.
Yep. It's 10:37 for me, so I got a few hours yet.
Mhm.
Anyway, excuse me. I'll be right back.
Alrighty. I'm just giving us a chance to see any satellites or other items that may be passing in front of the moon. Just increase the brightness ever so slightly. That's too slightly. Alright, that's good. So when we zoom in, you'll see a little tiny black dot if it's a satellite. And most likely it's going to be moving this way. Because the moon is, right now, it's upside down. It's flipped up for us right now. And so satellites usually go west to east. So west is that way, to the upper left. And east is down there. So when you see a satellite, if it's moving across, you'll see a dot that's moving this way generally. Might move on a slight angle if it's a Starlink satellite. But the Starlink satellite would be pretty small. But we'd still see it. Okay. Rogue will say, Rogue said, do we know what satellite it is? As a matter of fact, yeah. The way that works is we see how it's going across the moon. We calculate how long it takes to cross a certain feature of the moon. If it's a Maria, we measure using Lunar Reconnaissance Orbiter Quick Map. We measure the path on the Quick Map and get the distance that it actually traveled. And knowing how far away the moon is and how fast it crossed that amount of time. Again, it's a projection, remember. We look at the size of the feature, like the size of the moon is 30 arc minutes from one side to the other. So a feature like this might only be a couple of arc minutes. So if we measure the size and convert that size to what are called arc minutes, and knowing how fast it crossed those number of arc minutes, that tells us the speed it's traveling. And the speed that it's traveling tells us how high it is off the Earth. Because when you have something close to the Earth, like the International Space Station, it's traveling at about 252 miles up. And the speed it's traveling at is 17,000 500 miles an hour. It crosses the moon in a blink. If you blink, it crosses the moon in that amount of time. It doesn't go slowly across the moon. It just goes, it's gone. It's just a blink. But satellites that are in higher altitude take time. And the farther up they are, the smaller they'll be and the harder they are to see. But some of them are actually very visible. And undoubtedly, we had some pass through our view tonight. But we just didn't know it. No? Dean Bustador says, going to bed now. Thank you, Mark and Daryl, everyone, for a great night of astronomy. Oh, thank you so much, Dean. So nice to see you. Thank you so much for helping us out as well. And C&D Boy agrees. Yep, very cool. So good night, Dean. Later, skater, says Toner. That's funny. Yeah.
I hate daylight savings time.
Yeah, it ruins astronomers all over the world. Except in Arizona, they don't change their time.
Yeah. Neither does Hawaii. Some people forget that much of Indiana doesn't either.
Really?
Yeah.
That's got to be hard to live there. Because you go to the next town over and theoretically have to reset your watch.
Yeah.
They're just trying to make people nuts.
I don't deal well with daylight savings time. The effects on the body, they've documented that like accident rates go up,
Mm-hmm.
and people have more heart attacks and stuff. The effect is the same exact thing as jet lag.
Yeah,
And
it's just an hour, but still, it's significant.
yeah, it's enough to throw off your system.
Oh, yeah.
And it always takes me about a week or 10 days to adjust. And last year I noticed some ways I never did adjust to it. It's like when the time changes and your pets know it, but you don't, that they're expecting their dinner at a certain time. Same thing happened to me last year, that when we went to daylight savings time, well, all of a sudden my dinner time was an hour later, and I had a hard time adjusting, but once I did, when standard time came back, I was still stuck on the later time, which is why I've been eating dinner so late here lately.
Well, we start at 9:45 for you. Because you said that 9:45 is just about when you're done with your dinner.
7:45 for me.
Yeah, 9:45 for me, yeah. Yeah. Wow. All right. Well, I think that I think we're just getting ready to close up shop for tonight. So what I'll do, actually, might be kind of cool. I will actually, I will show you the closing process. All right, so what we're going to do here is we're going to take the telescope and we're going to move it to its position where we put it to bed. Okay, so that's called the park position. So it's going to go now. The moon's going to disappear. Goodbye. And the telescope is going into its position. It's got a long barrel on it, as you can see. And then it comes down below the roof. Okay. And we are now parked. So the telescope is ready to go to bed for the night. So I can basically disconnect it now. And then I bring up my program I wrote to do all this fancy stuff. And I shut off power to the telescope. And I close the roof. And there we go. 2,600 miles away, the roof is closing on a building. And people look at it going, what the heck's going on? Okay. So that's the Benson scope. Shut down for the night. It's that simple. It's all it takes. And now I can close things down and so forth. And I'll come back to do the rest. Meanwhile, over here in Wickenburg, okay, we can do the same thing. We're going to park the scope as well here. Alright, and so when we park the scope here, let me just do that. Let me come back here and see if we can move us over a little more. There we go. And zoom out. So here is, we'll fit our width in here. There we go. And now we can park our scope. And you'll watch the scope park now. Same as the other. There it goes. It's moving down to its park position right there. There it is. And you'll see up here, it'll then say, turn the telescope off when we get to the final position. And there it is. So we can turn it off. And now what we'll do is just to show you what's going on. I know that's doing that wacky thing. But here's the telescope down below. And what we'll do now is we'll close the building here as well. So there it goes. The roof closes on the building there and there. And we are now done for the evening.
Don't forget to shut down Wickenburg.
This is Wickenburg. Oh, I'm sorry. I'm in Wickenburg right now. You don't see it. Sorry.
Right.
Thank you.
Okay.
Yeah, they're seeing it. You're not. That's unfortunate. I can only have one window at a time. All right, guys. Well, you have a good night, and we will see you a little bit, well, later on. I'll stream again in another day or two so we can actually see the Aristarchus Plateau and so forth, and maybe the sky will be a little bit more stable. Okay? So, thank you guys for coming. Hope you enjoyed this double observatory tour tonight. And we will see you on the other side. So, good night, everybody.
Good night, all.
Stars so bright in the sky. On Arizona nights they fly. Nebulae in colors rare. Galaxies beyond compare. Sky tour in the night so clear. Brings the universe near. Real-time wonders to see. Streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds. Stories of the cosmos told. Through the lens, a distant stars beyond the sky. Sky Tour shows us the way. Every night a new display. Lift your eyes to the skies, universe in all its light. Sky Tour is bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky Tour is bringing the view.